This question reads, the common ratio of a geometric progression is 2. If the fifth term is greater than the first term by 45, find the fifth term. Here we are given that our common ratio R is equal to 2 and N is equal to 5. We are looking for our fifth term and we can denote that as our T5. How do we proceed to solve this? I would like you to recall our basic formula for geometric progression, which states that our Tn is equal to AR raised to the power of n minus 1. You can also represent Tn as An. In this formula, our A denotes the first term while our R denotes the common ratio. We are going to have that our T5 will be equal to AR raised to the power of 5 minus 1. From here, our T5 will be equal to AR raised to the power of 4. We are going to substitute the value of R into the above equation, and this will yield T subscript 5 will be equal to A times 2 raised to the power of 4. But 2 raised to the power of 4 is 16. Hence, we are going to have that T subscript 5 will be equal to 16 times A. Let's call this equation 1. But you have to recall that we're told that the fifth term is greater than the first term by 45. This statement implies that our T5 will be equal to T1 plus 45. Our first term T1 is denoted by A, and we are going to substitute the value of our T5, which is 16A, and this is going to yield 16A equal to A plus 45. From here, we are going to collect like terms, and this is going to yield 16A minus A, which is equal to 45. Proceeding further, we are going to have that our 15A will be equal to 45. If we divide both sides by 15, we are going to have that our A will be equal to 3. Having gotten our value for A, we are going to proceed to find the fifth term. Recall from equation 1, we had that T5 is equal to 16 times A. Proceeding further, we are going to have that T5 is equal to 16 times, but our value for A is 3. Hence, we are going to have that T5 is equal to 48. Hence, we can conclude that the fifth term is 48. This question reads, if the second term of a geometric progression is 6 and the fourth term is 54, find A, the first term, B, the fifth term. I would like you to note this. In a geometric progression, the ratio of the consecutive terms is constant. To solve this problem, we are going to deploy our formula for geometric progression. Recall that Tn is equal to AR raised to the power of n minus 1. Let's analyze our fourth term. We are going to have that T4 will be equal to AR. We are going to substitute 4 in place of n, 4 minus 1. Hence, we are going to have our T4 will be equal to AR raised to the power of 3. Also, we are going to have that our T2 will be equal to AR raised to the power of 2 minus 1. Here we can conclude that our T2 is equal to AR raised to the power of 1, which is the same thing as AR. Hence, we can say from our fourth term that AR raised to the power of 3 is equal to 54. And from our second term, we can say that AR is equal to 6. From here, we can see that if we divide these two equations, then it will be easier for us to eliminate A, thereby making it easy for us to find R, which is our common ratio. Hence, we are going to have that our AR raised to the power of 3 all over AR is equal to 54 divided by 6. this and this will cancel. Applying the laws of indices, we are going to have r raised to the power of 3 minus 1 will be equal to 9. Hence, we are going to have that r squared will be equal to 9. Therefore, our r will be equal to square root of 9, which is 3. Please note this. We can use any of these equations to find our first term. Let's deploy equation 2 in solving our first term. We have that our a times r is equal to 6, but our r, which is our common ratio, is 3. We are going to have that a times 3 is equal to 6. Making a the subject of formula, we are going to have that our a will be equal to 6 over 3, which is equal to 2. Therefore, our first term a is equal to 2. That is our answer. How can we find our fifth term? Recall that Tn is equal to ar raised to the power of n minus 1. Here we are going to have that our T5 will be equal to ar raised to the power of 5 minus 1. Our T5 is equal to ar raised to the power of 4. But our first term a is equal to 2 and our common ratio r is equal to 3. By substituting the values, we are going to have that our T subscript 5 will be equal to 2 times 3 raised to the power of 4. 3 raised to the power of 4 is 81. Hence, we are going to have that our T5 will be equal to 2 times 81. 2 times 81 is 162. Proceeding further, we are going to have that our T5 will be equal to 162. That is our final answer. Let's go ahead and solve this question. This question reads, the first term of a geometric progression is 5, while the third term is 45. Find the sum of the first 8 terms. We are going to deploy our formula to solve this problem. We have that Tn is equal to ar to the power of n minus 1. We are told that the third term is equal to 45. That means that our T3 will be equal to ar raised to the power of 3 minus 1, which is equal to ar squared. Also, we have that our T1 is equal to ar raised to the power of 1 minus 1, and this is equal to a. We are told that the third term, which is ar squared, is equal to 45, while the first term, which is a, is equal to 5. Looking at these two equations, we realize that it's easier to eliminate a by division. Hence, we are going to have that our ar squared all over a will be equal to 45. Proceeding further, we are going to have that our r squared is equal to 9. Therefore, our r is equal to 3. But recall, we were told to find the sum of the first 8 terms, and it's very important you note this. Since our common ratio is greater than 1, we are going to deploy this formula. We will be substituting our values into this formula to find our sum. Our a, which was given to be the first term, is equal to 5, and our r is equal to 3. Proceeding further, we are going to have that the sum of the first 8 terms will be equal to, recall our value of a was given to be 5, our r is 3, and our n is 8 minus 1 all over 3 minus 1. Hence, we are going to have that our sum will be equal to 5. 3 raised to the power of 8 is 6,561 minus 1 over 2. Proceeding further, we are going to have that our sum will be equal to 5. 6,561 minus 1 will yield 6,560 divided by 2. Proceeding further, we are going to have that our sum will be equal to 5 times 6,560 is 32,800 all over 2, which is 16,400. This is our answer. In our next video, we will be solving a lot of practice problems. Do well to like and subscribe to my channel. Thank you.